Hello guys, you've watched the first two videos on calculus. So today we are going to continue with maximal and minimal values and also points of inflection. Now, if y is a continuous function of x, y is a continuous function of x, is a function of x. It's a continuous function of x because if x receives an increment, which is del x, if x receives an increment del x and y also receives an increment or decrement of del y, then y as a function of x is said to be a continuous function. Now, if y is increased, that implies that our del y must be what? Positive. If y is increased, our del y must be positive and del x is also positive. If y is increased, del x is what? Positive. So the limit of the rate of change, that's del y all over del x, that is my dy dx, must be positive if y is increased. Now also, if y is decreased, our del y must be negative because it is decreased. So the rate of change of the increment of y with that of x, that's del y del x, must be negative. So the limit of del y del x, which is equal to dy dx, must be negative. Now let's start with stationary values. Now let's consider a function. Consider this function y as a function of x, which is equal to x squared minus 4x plus 3. Now this function y is equal to x squared minus 4x plus 3. Y as x squared minus 4x plus 3. Now y is a function of x, then I can find dy dx. So here dy dx is 2x minus 4. That's 2x minus 4. Now here, if x is less than plus 2, taking value of x that are less than 2, that's 1. So 1 times 2, 2. 2 minus 4 is what? Minus 2. If I take 1.5, same thing, that's what? Negative. X less than 2, 1 is less than 2. So 1 times 2 is 2. 2 minus 4 is what? Is minus 2. That means y is what? Is decreasing. And if y is decreasing, that means my dy dx is negative. My dy dx is negative because if I take value of x less than plus 2 and input it here, 1, that's what? Minus 2. Now if x is greater than plus 2, what will happen? Value of x greater than plus 2, let's say 3. 3 times 2, 6. 6 minus 4, that's 2. So that means y is increasing. So 6 minus 4, that's 3 times 2. 6 minus 4, that's plus 2. Positive. And dy dx is also positive. But if I take value of x, which is equal to 2, if I take value of x, which is 2, now, if x is equal to 2, that's 2 times 2, that's 4. 4 minus 4 is what? Is 0. That implies that dy dx is 0. So my dy dx is neither increasing nor decreasing because the value when x is equal to 2 is what? Is 0. So dy dx is neither increasing nor decreasing. So this function has a stationary point at x is equal to what? 2. So the stationary point is stationary. It's neither increasing nor decreasing. So the stationary point is when dy ds is equal to what? 0. That's the stationary point, and dy ds is equal to 0. Now another one is the turning point. The turning point. The turning point. Now what is the turning point? Now when the curve or the value of a function are decreasing before, when the value of a function are decreasing before, let's say decreasing before, and increasing after, like decreasing before and increasing after, then dy dx is negative if it is decreasing before and increasing after. But if dy dx, when the value is increasing before and decreasing after, then we can say that our dy dx is positive because it is increasing before and decreasing after. Now if dy dx is equal to 0, neither increasing nor decreasing, and it changes sign, such points on the curve are called the turning points. Now there's this point to note about stationary values and turning points. They both have this essential point, that is they both have essential condition, which is dy dx taken as what? As 0. Yeah, for stationary value dy dx is what? Is 0, and for turning point dy dx is what? Is 0. It is the behavior of the differential coefficient that matters, that differentiates the function from the stationary values and what? And the turning point. But they both have this what? Essential condition, dy dx taken as 0, dy dx taken as 0. Now under the turning point, we have this question: for what value of x is there a turning point? Is there a turning point on the curve? Is there a turning point on the curve y is equal to 2x squared minus 6x plus 9? Now for what value of x is there a turning point on the curve y is equal to 2x squared minus 6x plus 9? Now let's take dy dx, since y is a function of x, so that's 4x minus 6. Now this is 4x minus 6. When we take the value of x, if x, for value of x, and remember it is turning point, we can go for the dy dx, which is equal to 0. That's the stationary point. Now for stationary point, the stationary point, that's the point when dy dx is what? Is 0. Now stationary point, 4x minus 6 is equal to what? Is 0. Now this is 4x minus 6, which is equal to 0. The same thing as 4x is equal to 6, and x is 6 over 4, which is 3 over 2, as what? 1.5. Now for values of x less than plus 1.5, what will happen to this? When we input 1.5 here, that's 3 over 2. So that's 4x minus 6. 4x minus 6. If we input value of x less than or equal to what? 1.5. That, let's say 1. So that's 4, 1 minus 6. That's what? Minus 2, which is what? Negative. So dy dx is negative. So if dy dx is negative, that means the function is decreasing. The function is what? Decreasing. Now for values of x now greater than 1.5. So let's say 3 times 4, 12. 12 minus 6, that's positive. So dy dx is positive. Then we can say that we can conclude that the function is increasing. So the function is dy dx is decreasing before and increasing after. So that means there is a turning point at what? X is equal to what? 1.5. There's a turning point. Dy dx is what? Decreasing before and increasing after. So we can say that as the function is decreasing before and increasing after, there is a turning point. There is a turning point at x equal to 1.5. There is a turning point at x is equal to 1.5. Another one is examine y is equal to 1 minus 2x minus x squared for turning point. Now for you to examine these as turning points, the first thing to do, find the derivative coefficient of the function. That's minus 2 minus 2x. Then after, you take the stationary point. The next step, that's stationary point where dy dx is what? Is 0. So that's minus 2 minus 2x is equal to 0. So minus 2x is equal to 2, x is equal to minus 1. So that means there's a stationary point when x is what? Minus 1. There is a stationary point when x is equal to minus 1. Now let's find the values. Now if x is less than minus 1, if x is less than minus 1, value of x less than minus 1, that's minus 2. So minus 2 is less than minus 1. Minus 2, that's minus 2 minus 2 plus 4, that's 2. What happened? Dy dx is positive. So that means the function is increasing because dy dx is positive. Now for value of x, if x is greater than minus 1, note, always use less than, then after, greater. Now if x is greater than minus 1, let's say 2. So that's minus 2 minus, that's 2. Minus 2 minus 2, that's minus 4. So dy dx is negative. The function is decreasing. The function is decreasing. So yeah, dy dx is increasing before and decreasing after. So we can conclude that the stationary point is also a turning point. It's also a turning point at x equal to minus 1. Now the next thing here is the maximum and minimum values. The maximum and minimum values. The maximum and minimum value. The maximum and minimum value. Now let's consider this curve. Y is equal to x minus 1 and x minus 2 and x minus 3. Now this curve will vanish if, when I say vanish, that will be, everything will be equal to what? 0. This curve will vanish if x minus 1 is equal to 0, if x minus 2 equal to 0, and if x minus 3 equal to 0. Yeah, that means x is 1 and x is what? 2. X is what? 3. So if we input the values here, that means what? Y is what? 0. So the function vanishes when x minus 1 is equal to 0, y minus 1 is equal to 0, and x minus 3 equals to 0. So if the function is a continuous function, when I say continuous function, I mean if there's an increment in x, there will be a corresponding increment or decrement in what? In y. So now let's consider between these points, x minus 1, x minus 2, x minus 3. Now let's consider the value between x is equal to, this is 1, 2, and 2, and 3. Now between x is equal to 1 and x is equal to 2, and also between x is equal to 2 and x is equal to 3. Now if x is greater than 1, is less than 1, what will happen? If x is less than 1, value of x less than 1, let's say 0.5. So 0.5 minus 1, that's negative, negative, negative. Negative times negative, positive, that's what? Negative. So that's, y is what? Y is always negative. Also, if x is greater than 1 and less than 2, that's 1.5, greater than 1 but less than 2, 1.5. So 1.5, positive, negative, negative, positive, positive. That's negative times negative is positive, then it's positive is what? It's positive. So that means y is positive. And also if x is greater than 2 and less than 3, what will happen? That's 2.5, positive, positive, negative, positive. Times negative is what? Negative. So y is negative. Y is negative. So if x is greater than 3, what will happen? Y is always what? Positive. Greater than 3, 4 minus 1, 4 minus 2, 4 minus 3. So y is always what? Y is always positive. So if we multiply the functions, this function, x minus 1, x minus 2, x minus 3. If we multiply the function, we have y is equal to x power 3 minus 6x squared plus 11x minus 6. So if we find the derivative coefficient of the function, we get 3x squared minus 12x plus 11. That's it. So 3x squared minus 12x plus 11. Now the stationary point when we divide the x is what? Is taken as 0. So finding the stationary point, that's 3x squared minus 12x plus 11 equal to 0. If we factorize this, that to get x is equal to 1.42 and x is equal to 2.58. Now if we substitute these values into our function, so we get the values of turning points. Substitute these values into this. If x is 1.42, substitute here. If x is 2.58, substitute here. So we get the value when x is 1.42 as y as plus 0.385 and y as what? And this as what? Minus 0.385. So we can conclude that y has a maximum value of 0.385 when x is equal to 1.42, because this is what? Positive. And y has a minimum value of minus 0.385 when x is 2.58, because this is the value of x, which is negative, that's the minimum, and positive, that's the maximum. Now also we go to the test for minimum and maximum points. Test for minimum and maximum points. Now for maximum points, if the function is increasing before and decreasing after, dy dx must be positive. Dy dx must be positive before and negative after. The function is increasing, that's positive before, and after decreasing, that's negative after. Now for the minimum point, if dy dx must be negative before and positive after, the point is what? The point is minimum. The point is minimum. Now, these are one of the tests of minimum and maximum points. The first test is if the function is increasing before and decreasing after, you can just conclude that it is what? Maximum. But if it is decreasing before and increasing after, positive before and positive after, negative before and positive after, that's the point is what? Minimum. Another test is the sign of the second derivative coefficient. The sign of the second derivative coefficient. So for the maximum point, dy dx is positive before and negative after. At the maximum point, dy dx is what? Decreasing. So that means the 2y over dx squared must be negative. That's the second derivative coefficient. If it is what? Negative, that means it is what? It is maximum point. But if for the minimum point, dy dx is negative before and positive after, but the second derivative coefficient, if it is what? Positive, then it has what? A minimum point. Thank you for watching.